I want you to imagine something really simple for a second. Just imagine you're holding a completely normal coin.
Right.
You flick your thumb, the coin tumbles through the air, and, you catch it. You slap it down the back of your hand.
Okay, I'm with you.
So you lift your hand, and it's heads. Now, obviously, you know exactly what happened to the heads outcome, right?
Yeah, I mean, it became your physical reality.
Exactly. You're looking right at it.
Yeah.
But I really want you to think about something else. What physically happened to the tails outcome?
Well, see, most people, and honestly, like most traditional physicists over the last century, they would tell you that the tails outcome just vanished.
Right. Like it just poofed out of existence.
Exactly. The assumption is it didn't happen, therefore it just, doesn't exist. It's treated as this mathematical ghost that gets permanently relegated to the realm of pure imagination.
But what if it didn't just vanish? I mean, what if we've been looking at the universe entirely the wrong way this whole time?
It's a huge question.
It is. And what if standard physics is just, sweeping the biggest clue to our universe right under the rug?
Yeah.
Because that exact question is the foundation of our mission today. We are doing a deep dive into an incredibly ambitious, genuinely mind-bending theory.
Truly mind-bending.
It was formulated by the author Alejandro Cariatti Martelloni. And if you follow theoretical physics on YouTube, you probably know him from the channel at Dixitius.
Right. His work there is really fascinating.
Oh, absolutely. Yeah. So we are unpacking his paper today. It's called Null Potentiality Architecture, or in its original Spanish, Teoría del 0% de realidad.
And the core thesis we're exploring today, it completely rewrites what reality and, unreality actually mean.
Yeah, because Martelloni is basically suggesting that the unflipped tails, right, the quantum events that did not happen, he's saying they might actually be the missing puzzle piece that makes up, like, the vast majority of our physical universe.
Which sounds wild, but to understand why a framework this radical is even entering the conversation, we really need to acknowledge the current state of modern physics.
It's messy right now, isn't it?
It is deeply messy. We are currently sitting on top of two massive, unresolved, and frankly kind of embarrassing crises in the field.
Right.
The first one is a profound structural fracture. On one side, we have quantum mechanics, right?
Which works perfectly for the tiny stuff.
Exactly. It provides these incredibly precise, deterministic laws for the microscopic world. Atoms, subatomic particles, all of that.
Yeah.
But then on the other side, we have Einstein's general relativity, which is this beautifully continuous geometric theory governing gravity and, the macroscopic world of stars and galaxies.
And the problem is they absolutely refuse to talk to each other.
They despise each other, mathematically speaking.
I've always heard it described as like trying to play a vinyl record on a laptop.
That's a great way to put it.
The systems are just fundamentally incompatible at the source code level.
Yeah, they describe entirely different realities. I mean, general relativity requires space-time to be perfectly smooth and continuous, kind of like a stretched sheet of rubber.
Right.
But quantum mechanics, it demands that energy and matter come in these chunky, discrete, indivisible packets. Quanta.
So when you try to force them together?
To calculate what happens in a black hole, for instance, or at the literal moment of the Big Bang.
The math just explodes, right?
The mathematics literally breaks down. You don't just get slightly wrong answers, you get infinities.
And in physics, infinity is basically a giant error message.
Exactly. The equations spew out infinite probabilities, which is just nature's way of telling us our underlying assumptions are completely wrong.
Okay, so that's crisis number one. And if that wasn't bad enough, we have the second crisis.
Yeah, the big one.
The vacuum catastrophe.
The vacuum catastrophe. This is perhaps the most glaring mathematical failure in the entire history of science.
That's a bold claim, but it's true.
It really is. According to quantum field theory, The absolute empty vacuum of space shouldn't actually be empty.
Even if you suck everything out of it.
Right. Even if you remove every single atom, every photon, every tiny trace of matter from a box, the space inside that box is still boiling.
Boiling with what?
With quantum fluctuations.
Yeah.
Virtual particles are just constantly popping into and out of existence, and this gives the vacuum a baseline energy.
But the problem isn't that the energy exists, right? The problem is how much energy the math says should be in that empty box.
Exactly. The math predicts a number so astronomically high, it honestly defies human comprehension.
It's absurd.
When theoretical physicists calculate the energy density of the quantum vacuum, the result is 10 to the power of 120 times larger than what we actually observe in the universe.
Okay, let's just pause and respect that number for a second.
Yeah.
10 to the power of 120.
Yeah.
That is a 1 followed by 120 zeros. I mean, it's a number larger than the estimated number of atoms in the entire observable universe.
It's massive. And if that much energy were actually present and interacting within our four-dimensional space-time, the repulsive gravitational force would be violent.
Like universe-ending violent.
Yeah, it would be so strong that it would have ripped the fabric of the universe apart within a fraction of a second after the Big Bang.
So no galaxies, no stars.
No planet, no atomic structures. You and I definitely wouldn't be sitting here doing a deep dive right now.
But obviously, here we are.
Right. The universe is relatively calm, so the defining question of modern cosmology really is...
Where's all that energy hiding?
Exactly. Which brings us directly to Martelloni's null potentiality architecture.
Yes. Because our mission today is to walk through his proposed solution to these exact problems.
And he is posing a question that honestly initially sounds like pure science fiction.
Oh, totally.
Yeah.
What if the biggest mysteries of the cosmos, dark matter, dark energy, even the bizarre mechanics of quantum entanglement.
Right.
What if they are all just the gravitational residue of unhappened quantum events?
Like, what if the universe is saving its receipts?
I love that phrasing. But to really test the structural integrity of that claim, we have to start at the absolute root of the problem, don't we?
We do. We have to look at quantum superposition and the act of measurement itself. We need to look at the Schrödinger equation.
Okay, let's start there. Let's break down how it treats probability before an event happens.
So when we talk about a quantum system before it is measured, say, a single electron that could be spinning up or spinning down.
The math says it exists in a state of superposition.
Right. It is essentially doing both simultaneously. And this is mathematically described by a state vector.
So if you look at the raw equations on a chalkboard, you'll see this vector written out with coefficients, right?
Exactly. Usually it's a small c1 representing the probability amplitude of state 0 and a c2 representing the probability amplitude of state 1.
Okay, c1 and c2. So state 0 and state 1.
Those coefficients, c1 and c2, are really the heart of quantum mechanics. And the cardinal rule here is that the sum of their absolute squares must equal exactly 1.
Which basically means there's a 100% chance it's going to be something.
Yes. It's a strict mathematical way of enforcing that there is absolute certainty that the particle exists somewhere doing something.
Makes sense.
And as long as the system remains isolated from the rest of the universe, it evolves smoothly. It's deterministic.
It's playing out all possible histories at once, mathematically speaking.
Precisely. But then
we look at it.
Right. We look at it, or a stray photon hits it, or it interacts with a piece of laboratory equipment.
And suddenly that smooth, continuous evolution of multiple possibilities, it just hits a brick wall.
That is the notorious collapse of the wave function.
Okay.
The Copenhagen interpretation, which has been like the orthodox view since the 1920s, it states that the moment the system interacts with a macroscopic observer or the environment, the superposition just shatters.
It forces a choice.
Exactly. One of those probability amplitudes instantly becomes physical reality.
So let's say the C1 branch wins the quantum lottery.
Right. C1 wins. It becomes 100% real in our observable four-dimensional universe.
And what happens to the C2 branch? The tail side of the coin from our intro.
Well, standard physics tells us it just disappears. Poof. It evaporates into nothingness.
And I have to say, this is exactly where I've always felt a deep sense of frustration with standard quantum theory.
You're definitely not alone in that.
Because it feels like physics is acting like a shady corporate accountant, you know?
Ah, right.
Like, the books don't balance, so the accountant just burns the receipts and says, nothing to see here.
It is extremely convenient.
Right. Wait, you're telling me standard physics assumes this highly complex mathematical information, which literally dictated the physical evolution of a particle just a millisecond ago.
Yeah.
It simply vanishes into thin air. Doesn't that directly violate the conservation of information?
It's an epistemological paradox. The most intuitive, symmetric, and sacred rule in physics, even more fundamental than the conservation of energy, is that quantum information cannot be destroyed.
You can't just delete the universe's hard drive.
Right. The universe must be reversible. If you have the complete state of a system now, you should theoretically be able to calculate exactly what it looked like in the past.
But standard quantum mechanics routinely just shrugs and insists the unprojected branch is gone.
It just acts like it was never there.
Which means the universe is actively deleting its own history every single time a quantum event happens.
Yes. And the null potentiality architecture absolutely refuses to accept that premise.
Good. So what does it do instead?
It demands that the receipts are kept. And to do this, Martelloni leans heavily on the thermodynamic principles of black holes.
Specifically the Bekenstein-Hawking concept, right?
Exactly. In the 1970s, Jacob Bekenstein and Stephen Hawking proved something really profound. In the realm of gravity, information is inextricably linked to physical area and thermodynamic energy.
Okay, so information isn't just a concept.
Right. Information isn't just an abstract, massless idea. It has a literal physical footprint in the universe.
Oh, wow.
You cannot simply hit delete on a branch of the wave function without completely violating the laws of thermodynamics.
So if it doesn't get deleted, where does the C2 branch actually go? Because it clearly isn't here in the room with us.
Well, Martelloni proposes that the coefficient C2, the unhappened reality, it actually encodes a highly specific, measurable quantity of what we call entanglement entropy.
Entanglement entropy.
And because this entropy carries a baseline energy density, it physically cannot just evaporate.
So what happens?
Instead, the actual moment of collapse acts as a topological mechanism. The unprojected branch is physically evicted from our visible reality.
Evicted?
Yeah, it is forced across a dimensional horizon.
It's like sweeping the dust off the floor and actively shoving it under a rug. But in this case, the rug is a boundary between literal dimensions.
The operative phrase Martelloni uses here is holographic conservation.
Holographic conservation.
The mathematics of this architecture demand that the sum of what actually happens in our three-dimensional reality, plus all the unhappened branches hidden away beyond that horizon, must equal a universal constant over time.
So information is conserved across a multiversal ledger.
Yes, the ledger always balances.
This shifts our whole perspective on everyday events, honestly. Every single time a quantum choice is locked in,
yeah.
Every time a radioactive atom decays deep inside the earth, or like a photon from the sun bounces off a leaf instead of passing through it.
Right. Those are all quantum measurements.
That alternative reality, that what if, even dead, it's just moving to the cosmic basement.
That's a great way to visualize it.
But that immediately forces us to ask a structural question. What does a cosmic basement capable of holding infinite discarded realities actually look like?
Right. Well, to construct a basement with that kind of infinite capacity, we have to acknowledge the limitations of the standard model of particle physics.
Because the standard model only goes so far.
Right. It's fantastic for describing the interactions of forces in 3 dimensions of space and 1 of time.
Sure.
But it absolutely cannot accommodate a thermodynamic sink for discarded realities.
It's another room.
Exactly. So to build this architecture safely, to store infinite energy without instantly destroying our visible living room, we have to invoke superstring theory.
Ah, string theory.
Specifically, a highly rigorous framework known as type IIB supergravity.
Okay, type IIB supergravity. Now, I know string theory famously comes with a very strict set of architectural building codes, so to speak.
Very strict.
You can't just slap extra dimensions onto the universe wherever you want, right?
No, not at all. The mathematics of string theory are incredibly unforgiving. The equations literally require 10 dimensions to function without collapsing.
10 dimensions.
If you try to run the calculations for string interactions in our familiar 4 dimensions, you get impossible anomalies.
Like what?
You get negative probabilities, which obviously make no mathematical sense, and you get tachyons.
Tachyons. Those are the hypothetical particles moving fast in the light.
Exactly. And they would completely destabilize the entire vacuum.
Right.
So the only way the math elegantly resolves into a stable universe is if space-time factorizes into 2 distinct geometric subspaces.
Okay, let's map out these 2 spaces so we have a clearer picture.
Sure. First, there is our observable universe. In type IIB supergravity, this is called a D3 brane.
D3 brane.
Think of it as a 4-dimensional membrane floating in a larger space.
Okay.
Everything we know, all our light, all our matter, stars, planets, and our daily lives, all of it is permanently glued to the surface of this D3 brane.
So we are literally trapped on the membrane.
We are entirely trapped on it.
And the remaining 6 dimensions. The basement.
They exist all around us, actually, but they are curled up into microscopically small, incredibly complex geometric shapes.
Called Calabi-Yau manifolds, right?
Yes, Calabi-Yau manifolds. And this hidden 6-dimensional space is collectively referred to as the bulk.
Okay, so we have the 4D living room, which is our brain, and the 6D microscopic basement, which is the bulk.
Perfect.
But as I understand it, early iterations of string theory treated this basement as just empty storage space.
Right, that was the initial thought.
Like he was just sitting there statically, not really doing anything.
Right. The original assumption relied on a mathematical condition called Ricci flatness.
Ricci flatness.
In a Ricci flat space, the extra dimensions are effectively a static, empty background geometry. They don't interact. They just provide the mathematical room for strings to vibrate.
But Martelloni's framework points out a severe logical flaw there, doesn't it?
A massive flaw.
Because you cannot continuously dump the dense energetic residue of an infinite number of unhappened quantum realities into the bulk and expect it to remain empty and static.
No, it's physically impossible. The geometry has to react.
Right. It's like if you are continuously shoving pressurized gas into a sealed tank, eventually the walls of the tank are going to feel the structural stress.
That structural stress is exactly what we're talking about. And it's represented by a crucial mathematical concept called the warped metric.
The warped metric.
In the supergravity equations, there is a specific term called the warp factor. It's usually written as e to the power of 2a of y.
Okay.
And what this factor demonstrates is that the bulk is highly plastic. It actually deforms.
So it's not a rigid tank.
No. When the density of residual energy, which is the flux from all those quantum collapses, when that is injected into those extra dimensions, it creates massive internal tension.
Oh, wow.
The actual geometry of the bulk actively flexes, bends, and warps to accommodate this influx of information.
I want to try and visualize this tension because bendy math is kind of hard to picture.
It is.
Instead of a simple tank, imagine the bulk is like a massive pressurized deep sea submersible.
Oh, okay. What's wrong with that?
So the ocean pressing down from the outside is the fundamental tendency for extra dimensions to want to collapse or pinch off.
Yes.
But the internal air pressure, keeping the hull intact, keeping the walls propped up against the crushing deep, is the literal weight of all the things that didn't happen in our reality pushing outward.
That is a much more robust mechanical analogy, honestly. The architectural integrity of the universe relies on that exact internal pressure.
That's incredible.
You know, in the history of physics, there is an old philosophical concept called Mach's principle.
Proposed by Ernst Mach, right?
Yeah.
Late 19th century.
Yes. He suggested that the inertia of any object, so its fundamental resistance to being moved, is determined by the gravitational influence of all the other matter in the universe.
Einstein was heavily inspired by that.
He was. Well, Martelloni takes Mach's concept and scales it up to the structural geometry of the cosmos itself. He creates what he calls Mach's dimensional principle.
Mach's dimensional principle. How does that translate to our pressurized submersible analogy?
It dictates that the very existence, the physical size, and the topological stability of those 6 extra dimensions are entirely propped up by the dynamic pressure of the unhappened quantum fluctuations.
Wow.
The air keeping the submersible from imploding is the mathematical tensor representing the flux of discarded information.
Okay, let's take that to its logical extreme conclusion then.
Okay.
If the universe suddenly stopped making quantum choices, like if every superposition just froze and nothing ever collapsed again, would the submersible implode?
It would be an unmitigated disaster for physics.
Oh, really?
Literally. If you somehow purged the universe of this discarded quantum information, that flux tension inside the bulk would just drop to 0.
And without the pressure.
Without that internal architectural pressure, the extra dimensions would suffer topological collapse.
They would just crunch.
They would crunch down into microscopic singularities. Or, depending on the exact manifold geometry, they might actually suffer catastrophic decompactification, wildly ballooning out of control.
And what happens to us on the D3 brain if the basement either crunches or balloons?
Oh, the physics of our observable 4-dimensional reality would be instantly annihilated. Yeah. The fundamental constants of nature, the exact strength of gravity, the mass of an electron, the speed of light, they are all determined by the precise shape and size of those extra dimensions.
So if the bulk goes, we go.
If the bulk collapses, our reality goes right with it. The stability of our entire matrix dynamically depends on the weight of unexecuted potential.
That is just profound. Our physical reality, the actual ground we walk on, is literally structurally supported by the ghosts of everything that didn't happen.
It completely demands a total paradigm shift in how we view cause and effect.
It really does.
Yeah.
But this brings up a very serious mechanical problem in my head.
What's that?
Well, we understand the architectural layout now. We know our 3D reality is on the surface brane and the 6E Calabi-Yau basement is beneath us, structurally supported by the pressure of these what-ifs.
Right.
But how exactly does the energy of an unhappened event travel from our reality into that basement? What is the actual plumbing connecting the two?
To map the plumbing, we really have to stop treating wave function collapse as just a mathematical trick. We have to look at it as a physical gravitational event.
Yeah.
And to do this, Martelloni builds heavily upon a fascinating theoretical framework called the Diossi-Penrose model, or the DP model.
Named after the physicists Lajos Diossi and Roger Penrose.
Yes. So for decades, the Copenhagen interpretation argued that a measurement required a conscious observer, or at least like a macroscopic measuring device, to force a particle to choose a state.
Right, the whole tree falling in the forest thing.
Exactly. But Penrose and Diossi fundamentally rejected that. They argued that bringing consciousness into fundamental physics is just too mystical.
It does feel a bit magical.
It does. So they proposed that superpositions actually collapse spontaneously and objectively, driven entirely by the mechanics of gravity.
Wait, how does gravity, the force that pulls apples to the ground, force a tiny quantum particle to pick a definitive state?
Think carefully about what a superposition of position really implies, physically. If a particle with mass is in 2 places at once, it means its mass is literally in 2 places at once.
Right.
Now bring in Einstein's general relativity, which tells us that mass curves space-time.
Okay, I see where this is going.
If the mass is in 2 places, space-time itself is being forced to curve in 2 different mutually exclusive directions simultaneously.
You're asking the fabric of the universe to be convex and concave in the exact same location.
Precisely. And space-time inherently resists ambiguity. The universe abhors a geometric contradiction.
It makes sense it wouldn't like that.
This contradictory curving creates a literal structural tension in the fabric of space-time, which the DP model actually quantifies mathematically as an energy difference. It's often denoted as delta E.
So delta E.
And the larger the mass in superposition, or the further apart the two possible positions are, the greater this geometric tension becomes.
Okay, so a single tiny electron in superposition creates a very tiny tear, but a whole molecule creates a massive strain.
Yes. And there is a breaking point. Penrose calculated that when this structural tension reaches a specific threshold,
which I'm guessing happens fast for big things,
almost instantly for large macroscopic objects, but it can take a measurable amount of time for tiny isolated particles.
Okay.
Anyway, when it hits that threshold, the geometry of space-time literally snaps.
Snaps.
The superposition can no longer be sustained by the fabric of reality, and it collapses into a single definite state to resolve the gravitational paradox.
Okay, the space-time fabric snaps to resolve the tension. But, I mean, basic physics says snapping a taut rubber band releases energy.
Yes, it does.
In the standard DOC-Penrose model, where does the energy from that snap actually go?
That question has always been the Achilles heel of the traditional DP model.
Really?
Yes. For a long time, many theorists simply assumed the energy just dissipates back into our 3D space as random thermal noise, just microscopic bits of heat spreading out.
Well, that sounds plausible enough.
It does, until you do the math. Cosmological calculations show that if that were true, over billions of years of cosmic history, that constant heat generation from every single collapsing wave function, it would have completely fried the cosmic microwave background.
Because it's happening constantly everywhere.
Exactly. The ambient temperature of the universe would be unrecognizably hot. It blatantly violates the conservation of energy laws we observe today.
So the DP model is brilliant, but it leaks heat. Enter the null potentiality architecture to fix the plumbing.
Exactly right. Martelloni proposes that during the microscopic fraction of a second, when that geometric snap occurs, the residual energy linked to the unstable superposition does not dissipate into our 3D space.
Because it cannot, or it would cook us.
Right. Instead, the energy is fired perpendicularly. It is shunted completely out of our phase space and channeled directly into the rotational and vibrational degrees of freedom of the compactified extra dimensions.
Wow. It shoots it straight down to the basement through a dimensional pipe. But what form does that energy take? It can't be regular heat or light if it's leaving our dimension, right?
It takes the form of ultraviolet gravitons. Gravitons are the hypothetical, massless elementary particles that mediate the force of gravity.
Yeah.
In string theory, the particles that make up you and me, like quarks and electrons, they are open strings. Their ends are permanently anchored to our 4D brain.
They can't leave.
Right. They are stuck. But gravitons are fundamentally different. They are closed strings, perfect little loops with no ends to anchor them.
Oh, because they have no ends? They aren't glued to our 3D living room? They can literally pass through the floorboards.
They are completely free to travel seamlessly into the bulk. So when the gravitational snap of the collapse occurs, it acts as a high-energy event of graviton emission.
Like a burst.
Yes. It injects pure gravitational momentum straight into the multiversal thermodynamic sink.
I want to really unpack this for a second because the scale of what you are suggesting is just staggering.
It is massive.
Every single time a uranium atom decays deep inside the Earth's crust, or, I don't know, a photon scatters inside the ultra-dense plasma of a star,
right,
or even a chemical bond forming in my bloodstream, that event acts like a tiny microscopic hydraulic pump.
Yes.
It is physically shoving gravitational energy sideways out of our observable universe.
That is the exact mechanism Martelloni is outlining here. It is a profound shift in perspective.
It really is.
It transforms quantum mechanics from this series of random stochastic accidents into a continuous, relentless, causative cycle.
It means our observable universe, every burning star, every swirling nebula, every living cell is essentially a massive churning engine.
Yes. And the primary exhaust of this engine is probability energy, constantly pumping mass into the multiversal reserve.
Okay, so the hydraulic pump fires the ultraviolet gravitons sideways into the bulk. The energy has arrived in the basement.
Safely in the bulk.
But energy can't just float around infinitely as abstract mathematical potential. It has to act on something. What is physically down there in the Calabi-Yau manifold to actually catch and store this massive influx of multiversal exhaust?
To find the catchers, we really have to zoom in on the fundamental building blocks of this entire framework, the superstrings themselves.
Okay, let's zoom in.
We have to completely discard the 20th century idea of point-like particles. In string theory, mass is not an intrinsic fundamental property.
It's not a barcode stamped on a particle at birth.
Exactly. It's entirely an emergent property. It is the direct result of a string's vibrational frequency and its mechanical tension.
So like plucking a cello string.
Yeah.
The more energy I put into plucking it, the harder it vibrates. And through Einstein's E equals mc squared, that extra kinetic energy translates directly into more mass.
That is the standard mechanism, yes. When the ultraviolet gravitons pump energy down into the bulk, they encounter the swarm of closed strings floating through the extra dimensions.
Okay.
The strings absorb the gravitons and excite to higher harmonic modes. They vibrate faster.
Makes sense.
But because the extra dimensions are complex, compactified geometric shapes, often curled into circles or tories, there is a secondary, much more profound mechanism by which these strings can absorb and store energy.
What is that?
It relies on a supreme geometric condition in string theory known as T-duality.
Hold on. T-duality.
Yeah.
I want to stop the show right here because every time I read about T-duality, my brain kind of short circuits.
It's notoriously difficult.
Walk me through the literal physics of this because I know it is one of the weirdest concepts in the entire field.
It truly bends the mind, but it is absolutely essential to this theory. T-duality is a profound mathematical symmetry.
Okay.
It basically proves that a universe with a specific very small radius, let's call it r,
Okay, radius r,
is fundamentally physically identical to a universe with an incredibly massive radius, mathematically defined as the string length squared divided by r.
I'm going to need you to unpack that a bit more.
Yeah.
Are you seriously saying a universe the size of a single atom is physically indistinguishable from a universe the size of a galaxy?
Mathematically, yes.
How is that logically possible?
It is only possible because of how a string, unlike a point particle, actually experiences space.
Okay. Contrast them for me.
Think about a point particle. It only knows how to do one thing: travel through space like a car on a road.
Simple enough.
If the space is a tiny microscopic circle, the particle feels claustrophobic. It requires a tremendous amount of momentum energy to squeeze through and navigate that tight space. This is governed by basic quantum mechanics.
Okay, tiny space equals high momentum energy for a particle.
Got it. But a closed string has a superpower that a point particle lacks. Because it's a flexible loop, it doesn't just have to travel through the circular dimension.
What else do it do?
It can physically stretch and wrap around the dimension itself, hugging the circumference like a sleeve.
Oh, I see. So instead of just driving on the road, it can wrap itself around the entire planet the road is built on.
Exactly. This introduces a completely new quantum property called a winding mode, denoted by the letter W.
Winding mode W.
It literally counts the number of times the closed string has wrapped around the extra dimension. Now, if the dimension gets bigger, the string has to stretch further to wrap all the way around it, right?
Which requires more elastic energy.
Exactly. So a tiny dimension means high momentum energy, but low wrapping energy. A giant dimension means low momentum energy, but massive wrapping energy.
And T-duality proves that the total energy, the combination of momentum and winding, remains mathematically invariant whether the dimension is microscopic or macroscopic.
The equations mirror each other perfectly, but for our purposes, the critical takeaway here is that winding mode.
Let's go back to my rubber band analogy for a second.
Sure.
If I take a rubber band and stretch it tightly around a rolled-up magazine, I've added elastic tension to it. It is structurally taut.
Yes.
Are you saying that when the hydraulic pump fires the unreality of a quantum coin flip into the bulk. It forces these microscopic string rubber bands to stretch and wrap around the extra dimensions.
Yes.
The abstract what if actually crystallizes into literal physical elastic tension.
You have zeroed in on the most elegant, transformative part of Martelloni's entire architecture right there.
It's wild.
When the graviton injects energy into the bulk, it doesn't just make the string vibrate faster, it excites the string's winding modes.
Okay.
It forces the string to wrap tightly around a specific compact dimension, usually denoted in the math as dimension by one.
So it winds around by one.
Yes. The residual information of the unhappened reality is permanently confined. Abstract probability is literally transmuted into measurable multiversal mass and structural mechanical tension.
But wait, if I put a rubber band around a magazine, eventually it might snap. Or it could just slip off the end and release all that stored energy.
Sure, in the macro world.
Can't the string just unwrap itself over time?
No, and that topological permanence is absolutely key.
Yeah.
The dimension by one is a continuous closed loop.
So no ends.
It has no edges, no ends for the string to slip off of. The string is topologically locked in place.
Oh, what?
It is forced to hold that physical tension indefinitely, basically storing the quantum history of our universe like a physical hard drive.
Okay, so we have this massive hidden, locked-in mechanical tension accumulating right underneath the floorboards of our reality.
Right.
Billions of years of cosmic history, trillions of quantum choices a second, all winding up these microscopic rubber bands.
There's a lot of tension.
If we zoom out from the quantum level and look at this on a macro cosmic scale, what does that actually look like to us? Do we see it?
We do see it. In fact, cosmologists have been staring at it for decades, completely baffled by what they were actually looking at.
Really?
Yes. This brings us to the paper's first truly revolutionary testable conclusion. This accumulated gravitational residue of wound-up strings is dark matter.
Just let that sink in for a second. Dark matter isn't a mysterious, invisible particle floating through space. It is the physical weight of quantum history.
It elegantly solves a 50-year-old mystery. Standard cosmology, which is known as the lambda CDM model, assumes dark matter is some exotic, weakly interacting massive particle.
A WIMP?
A WIMP, right. That it was forged in the primordial heat of the Big Bang. But despite decades of searching, using the most sensitive underground detectors on Earth, isolating vats of liquid xenon to catch just one single interaction.
We have never found a single WIMP.
We have never found one.
But if Martelloni is right, the winding strings explained exactly why we can't find a WIMP. Because dark matter isn't a particle existing in our three-dimensional space at all.
Exactly.
It's structural tension in the sixth dimension, basically projecting gravity into our living room.
Furthermore, it perfectly explains the defining, most frustrating characteristic of dark matter: its extreme longevity and stability.
Right, because standard physics struggles to explain why dark matter doesn't decay into lighter particles or emit radiation over billions of years.
But in this architecture, dark matter is stabilized by topological conservation. To destroy a string with a winding mode of positive 1, so W11, it must directly collide and perfectly annihilate with a string that has an opposite winding mode of negative 1, W1.
It has to find an exact anti-knot to untie itself.
Exactly. But because the universe is actively expanding and these extra dimensions have a vast internal volume, the gas of wrapped strings is extremely dilute.
So they never meet.
The statistical probability of a W1 string finding a W1 string to annihilate with is practically zero.
Wow.
Therefore, this dark matter simply cannot decay. It just accumulates, exerting localized gravity and pooling around the structures that created it in the first place.
Okay, this completely flips the timeline of astrophysics on its head. I'm having a massive aha moment right now.
Let's hear it.
Standard astrophysics, like what you learn in an introductory astronomy class, says that right after the Big Bang, dark matter pooled together first.
Right.
It created invisible gravitational wells, and then regular hydrogen gas fell into those wells to ignite into stars and form galaxies. The standard model basically says that dark matter built the city.
That is the canonical sequence of cosmic evolution, yes.
But this model, reverses the entire arrow of causality. It's saying the stars in the galaxy, which are giant quantum measurement engines running trillions of fusion reactions a second, they are actively sweating out the dark matter.
Yes.
It's like saying the heavy city traffic generates the dense smog rather than the city being built because a cloud of smog was already hovering there.
The smog analogy is highly illustrative because it solves one of the biggest, most persistent headaches in observational astronomy, the baryonic Tully-Fisher relation, or BTFR.
I know Vera Rubin discovered flat galactic rotation curves, but what exactly is the BTFR?
When astronomers observe spiral galaxies, they find an impossibly tight, mathematically exact correlation between the amount of visible baryonic matter.
That's the burning stars and glowing gas.
Right. They find a correlation between that and the speed at which the outer edges of the galaxy rotate, which is entirely dictated by the mass of its invisible dark matter halo.
Right.
In the standard model, this perfect correlation makes zero sense. Dark matter and regular matter don't interact at all, except through gravity, so why should their masses perfectly, consistently match up in every single galaxy across the universe?
It's like finding out the amount of concrete in a city perfectly matches the number of birds flying over it. There's no logical reason they should sync up. How do standard physicists even explain it?
By basically brute forcing the math. Astrophysicists have to invent highly tuned, incredibly complex computer simulations involving feedback loops.
That sounds tedious.
It is. They simulate exploding supernovas violently pushing gas out of the galaxy, adjusting the parameters manually just to force the visible matter to match the dark matter profile we see in reality. It feels highly engineered.
But Martelloni's model doesn't need to force the math or invent feedback loops, does it?
Not at all. It's an inherent feature of the architecture. If a galaxy has more dense burning matter, if it has more stars, more active nebulas, more atomic collisions...
It is running exponentially more quantum collapses per second.
Yes. It is a heavier, more active engine injecting massive amounts of wave function exhaust into the bulk.
So it just naturally builds up more dark matter.
Therefore, over eons, it inherently weaves a proportionally thicker, heavier gravitational shell of wound-up strings around itself. The dark matter halo is a direct causal reflection of the galaxy's exact quantum history.
They correlate perfectly because one directly creates the other.
Exactly.
Okay, so if dark matter is the local accumulation of this unhappened energy, right? The smog hovering directly over the noisy city.
Right.
What happens when we look at the entire planet? What is the global effect of the extra dimensions constantly being pumped full of all this elastic tension across the entire span of the universe?
To answer that, we have to move from the localized mystery of dark matter to the global cosmic mystery of dark energy and the accelerating expansion of the universe.
Right, because since 1998, we've known the universe isn't just expanding, the expansion is actively speeding up. Something is pushing the galaxies apart.
And standard string theory has historically struggled deeply to explain this acceleration.
Why is that?
To stabilize the size and shape of the 6 extra dimensions so they don't wildly fluctuate and destroy our reality, theoretical physicists developed a mathematical framework called the KKLT mechanism, named after its authors Catrou, Kalosh, Lindbay, and Tribidi.
What does the KKLT mechanism actually do to the geometry?
It uses magnetic fluxes to create a thermodynamic valley or a potential well that traps the geometry of the extra dimensions, locking them into a stable shape.
Okay, sounds good so far.
But there is a massive catch. The pure mathematics of this stabilization valley naturally dictate that the universe should have a negative cosmological constant.
Like negative constant.
It strongly predicts we should live in what is called an anti-de Sitter space, or ADS space.
And what happens to a universe in anti-de Sitter space?
It crunches. An ADS universe has a geometry dominated by overall gravitational attraction. It should eventually halt its expansion and collapse back in on itself in a big crunch.
But obviously, we look through our telescopes, we measure the redshift of distant supernovas, and we see the exact opposite.
Right.
We live in a de Sitter space, a universe actively and aggressively accelerating outward.
So the rigorously proven math of string theory predicts a crunch, but observable reality shows a stretch.
How do string theorists resolve that glaring contradiction?
By manual intervention, essentially. They add an ad hoc positive mathematical term called the uplift term, denoted as V uplift, to physically force the energy valley out of the negative ADS territory and into the positive de Sitter territory.
Sounds like cheating.
Well, to justify this uplift term physically, they often propose injecting exotic hypothetical objects called antibrains into the deepest, most highly warped parts of the extra dimensions.
Okay.
It balances the equation mathematically, but many physicists feel it is incredibly artificial. It's a mathematical patch.
So we need the map to show the universe expanding. Let's just invent an invisible multiversal elevator to prop it up.
That is a fair critique of the standard approach, honestly. But in the null potentiality architecture, we do not need to invent artificial anti-brains or rely on mathematical patches.
Because we already have something.
We already have a massive, dynamically growing source of positive tension naturally building up in the bulk, the accumulated winding modes of the strings.
The elastic rubber bands.
Yes. Remember, these closed strings are wrapping around the compact dimension, getting tighter and tighter, multiplying by the trillions every single second.
Right.
As more quantum collapses happen, the sum of all these winding modes increases. This massive cosmic tangle of elastic strings exerts a powerful centrifugal tension outward against the walls of the extra dimension.
So if we go back to our pressurized submersible analogy, if you keep pumping more and more high-pressure gas into the hull, the walls are going to stretch outward. The internal pressure eventually pushes out against the surrounding environment.
Are you saying the mysterious dark energy that is actively pushing our visible galaxies apart is literally just the physical mechanical pressure of too much accumulated quantum history?
That is exactly what the mathematics of the model show. When that confined dimensional pressure is projected onto our four-dimensional macro reality, it manifests as a robust, positive source of repulsive energy.
Wow.
The required uplift term isn't a hack at all. It is the organic, inevitable result of the universe meticulously recording its own alternative histories.
That is breathtakingly elegant. It links the micro to the macro perfectly. But hold on. If dark energy is being actively created by quantum events and stars are constantly burning and particles are constantly decaying, does that mean dark energy isn't a static cosmological constant? Is it getting stronger?
You have hit on a critical consequence of the theory right there.
Yes.
This leads to a concept in cosmology known as thawing quintessence.
Thawing quintessence. In Martelloni's model, dark energy is not a static property of empty space. It is a dynamic, growing scalar field.
Because the exhaust keeps flowing.
Because the universe continues to harbor stellar fusion, radioactive decay, and active quantum measurements, the total multiversal ledger of wrapped strings is always increasing.
Right.
Therefore, the repulsive force pushing the universe apart must be dynamically thawing or growing over cosmic time.
But the beauty of theoretical physics is that it needs to be testable. Is there any way we can actually prove if dark energy is growing or if it's just a static constant?
We can absolutely test it, and that makes this theory empirically falsifiable, which is the gold standard of the scientific method.
How do we test it?
If dark energy were just a static, unchanging property of the vacuum, its equation of state, which is the mathematical ratio between its pressure and its density, would be a perfect, unchanging negative one.
Okay, -1.
But the null potentiality equations predict a very slight specific deviation from -1, a delta that changes depending on the redshift, or the specific epoch of the universe we are actually observing.
And we have the technological tools to measure that equation of state right now, don't we?
We do. Massive space probes like the Euclid telescope and large-scale cosmic surveys like the DSI project.
The dark energy spectroscopic instrument, right?
Yes. They are currently mapping the history of cosmic expansion with unprecedented three-dimensional precision.
And if they find a deviation?
If they analyze the data and find that dark energy's equation of state is varying slightly over time, if it is thawing, as the model suggests, it would be a monumental, paradigm-shifting piece of evidence supporting this exact string architecture.
Okay, this paints an incredibly unified, stunning picture of the cosmos. But I have to play the skeptic here for a minute.
Please do.
Because there's a glaring elephant in the room kind of paradox that I just can't shake.
Let's hear it.
If the basement of reality, the bulk, is literally holding the mass energy of an infinite number of alternative histories, capturing the exhaust of every single quantum choice since the dawn of time.
Right.
Why hasn't its collective gravity crushed our observable universe into a single localized black hole? How is it that we don't feel the crushing weight of infinite multiversal gravity under our feet?
It is the ultimate boundary question. If there is truly that much mechanical tension and mass accumulated in the bulk, the mathematics of general relativity suggests we should have been crushed into a microscopic wild singularity eons ago.
Right, so why aren't we?
To understand the universe's inherent shock absorbers, we have to look much closer at the highly warped geometry of the Calabi-Yau manifolds, specifically at topological structures known as Klebanov-Strassler throats.
Throats, like geological tunnels bored into the math.
Exactly like extreme geological tunnels.
Yeah.
Imagine deep, elongated, cone-like structures that bore profoundly deep into the fabric of the internal dimensions. When the extra dimensions become saturated with the tension of these wound-up strings, it induces severe asymmetries in the underlying geometry. It basically forces the manifold to extrude these massive, deep geometric wells.
Okay, so the winding strings dig these deep tunnels into the basement. But how does putting the dark matter in a tunnel stop its immense gravity from crushing the living room right above it?
Because of the mechanics of extreme gravitational redshift. Remember the warp factor we discussed earlier? The metric e to the power of 2a of y that dictates how space bends?
Yes.
As you travel down from our 3D brain deep into one of these Klebanov-Strassler throats, the warp factor gets drastically steeper.
Okay.
The math shows that the massive energy-heavy strings will naturally migrate down the gravitational gradient, sliding to the absolute bottom of these geometric abysses.
So they settle at the very bottom of the dimensional well.
Yes. Now, apply Einstein's core principle of general relativity. Gravity severely warps time.
Right, time dilation.
An object sitting at the bottom of a massive gravitational well experiences profound time dilation and energetic redshift compared to an observer sitting far away at the top of the well.
Oh, I see. It's like looking down a miles-deep well shaft.
Okay.
If someone lights a massive raging bonfire at the very bottom, the sheer physical distance and the extreme warping of the walls mean that by the time the light photons struggle up the shaft and reach your eye at the top,
yes,
their energy is so depleted that the bonfire just looks like a tiny, dim, harmless firefly.
That is a perfect, intuitive translation of the tensor physics. At the absolute bottom of the throat, the mass and mechanical tension of the strings operate at the immense crushing Planck scale.
To us.
But from the perspective of our 4D surface brain, looking down the throat, all that colossal infinite energy is exponentially suppressed. It is logarithmically attenuated by the geometry of the throat itself.
Wow.
To us, observing from the top, it appears ridiculously tiny, on the incredibly small scale of millielectron volts.
And let me guess. A millielectron volt just happens to exactly match the tiny observed value of the cosmological constant we see pushing the universe apart.
Exactly. It completely resolves the vacuum catastrophe. The energy is there. It is massive. But the Klebanov-Strassler throats act as the ultimate multiversal shock absorbers.
That's incredible.
They allow the architecture of the universe to store infinite mathematical potential without suffering a catastrophic structural collapse. The macro homeostasis of our observable reality is preserved entirely by optical geometry.
It's just astonishing. The universe literally hides its infinite weight in a dimensional optical illusion.
It really does.
But before we wrap up, we have to touch on the final piece of the paper, because this hidden geometry of tunnels and rubber band strings, it takes things one step further.
It does.
It uses this exact plumbing to explain what Einstein called the weirdest, most frustrating phenomenon in all of quantum mechanics, right?
It does. It provides a purely geometric mechanical solution to quantum entanglement.
The famous spooky action at a distance.
Yes.
For our listeners who might not be deep into quantum theory, entanglement is when two particles become mathematically linked. And no matter how far apart you separate them, You could put one in a lab in New York and the other on a planet in the Andromeda galaxy.
Right.
If you measure the spin of the first one, the second one instantly, simultaneously reacts and resolves its own state.
Which seems to directly violate the universal speed limit of light, which says no information can travel faster than c.
It has driven theoretical physicists crazy for nearly a century. How do these particles communicate their states instantly without exchanging a photon, a radio wave, or any physical signal?
It's a huge paradox. But in recent years, titans of modern physics like Juan Maldacena and Leonard Susskind proposed a theoretical bridge to solve this, a conjecture known as ER equals EPR.
What do those acronyms stand for in this context?
EPR stands for Einstein-Podolsky-Rosen, which is the famous 1935 paper that first highlighted the paradox of quantum entanglement.
Okay, and ER?
ER stands for Einstein-Rosen bridges, which is the rigorous scientific term for wormholes in general relativity.
Wormholes.
Got it. The ER equals EPR conjecture brilliantly suggests that entangled particles are secretly connected by a microscopic, untraversable wormhole. They are physically linked through the bulk.
So a literal tunnel through space-time connects them, completely bypassing the normal 3D distance.
Yes. But Martelloni's null potentiality architecture elevates this from a purely abstract topological analogy to literal physical mechanical geometry.
How so?
Remember, in this framework, distance in our 3D world is essentially an optical illusion projected over the bulk.
Wait. Physical distance is an illusion.
In the deeper context of the bulk architecture, yes. Two entangled particles could be 1,000,000 light years apart on the flat surface of our 3D brain.
Okay.
But beneath them, extending down into the 6D bulk, those two particles are directly physically anchored to the exact same continuous closed superstring that winds through the compact dimensions.
So when a scientist in New York tugs on one particle to measure it, they are literally pulling on a microscopic tensile string hidden under the floorboards of reality.
Yeah.
And because the particle in Andromeda is tied to the exact same string, it instantly feels the mechanical tension.
Precisely. There is no magical communication, no superluminal transmission violating the laws of relativity and the speed of light.
It's just physical connection.
It is instantaneous mechanical tension transferred along a physical, highly tensile string that is operating orthogonally to our 4D space-time metrics.
It's like pulling a loose thread on the bottom of a sweater. The collar of the sweater reacts instantly, not because a signal traveled across the fabric, but because it is fundamentally, structurally, one connected object.
That is a brilliant analogy.
Yes, my mind is completely blown.
Yeah.
We have covered an immense amount of ground today, and I really want to do a rapid, structured recap to make sure I've got all the interlocking pieces of this puzzle together.
Let's trace the causality one more time.
Okay, we start with a quantum choice. A particle is in superposition. The gravitational tension of being in two places at once forces space-time to snap. The reality that didn't happen, the unprojected branch, doesn't vanish into nothingness. It is preserved as structural information and pumped perpendicularly as ultraviolet gravitons down into 6 hidden compactified extra dimensions.
Correct. Shunted right into the multiversal thermodynamic sink to preserve the conservation of information.
Down in that sink, that probability energy hits microscopic closed superstrings. It excites their winding modes, forcing them to stretch and wrap tightly around the compact dimensions,
Exactly.
transmuting abstract mathematical probability into literal, physical, elastic tension.
Crystallizing unreality into topological mass.
Then locally, around giant structures like galaxies that are churning out trillions of these quantum choices a second,
Right.
this massive accumulating tangle of wound-up strings looks to us like dark matter.
Right.
It provides the exact necessary gravity that holds the spinning galaxy together.
Neatly solving the baryonic Tully-Fisher relation and explaining exactly why dark matter is invisible and topologically stable against decay.
And globally, as the entire cosmos keeps pumping more of these wrapped strings into the extra dimensions, their collective growing elastic tension pushes outward on the structural walls of reality.
Yes.
And to us, observing from the inside, that geometric pressure looks like dark energy actively accelerating the expansion of the universe.
Thawing quintessence, basically lifting the cosmic potential naturally without the need for artificial anti-brains.
And the only reason all this hidden infinite multiversal mass doesn't crush us into a singularity is because it slides down into deep microscopic dimensional tunnels.
Clubbing off Strassler throats.
Right, where its massive gravity is heavily suppressed by extreme redshift.
Absolutely.
And D is the final piece of the puzzle. These exact same strings act as the literal physical structural connection between entangled particles across vast cosmic distances.
You have synthesized the mechanics of the null potentiality architecture flawlessly.
It is a lot to take in.
It is a breathtaking unification of modern physics. I mean, it takes dark matter, dark energy, wave function collapse, and quantum entanglement, four of the greatest, seemingly unrelated mysteries of science.
Yeah.
And it explains them all as distinct, localized symptoms of a single, beautiful, underlying mechanism. The universe's absolute thermodynamic refusal to destroy information.
It is a stunning, deeply moving way to look at reality. It means the universe isn't just a passive, empty stage where random things happen.
No, not at all.
It is a meticulous physical record keeper of absolutely everything that could have happened. It literally honors every possibility.
It does.
And I want to leave you, the listener, with the final thought to mull over as you go about your day, building on this incredibly expansive view of the cosmos.
Okay, lay it on us.
If this theoretical architecture holds true, right? If every single quantum event, every wave function collapse, actively injects literal physical weight and structural tension into the hidden dimensions of the universe. Think about what is happening inside your own head right now. Your brain is a miraculous chemical and electrical powerhouse.
True.
The synapses firing between your neurons, the complex ion channels opening and closing to process information. These microscopic events are ultimately driven by the fundamental laws of quantum mechanics.
They absolutely are.
Which means every single time you make a decision, every time your neurons fire and collapse a superposition to form a concrete thought, a memory, or an action.
Wow.
Are you right now actively adding to the dark matter halo of the Milky Way? Is the sheer everyday act of human consciousness literally physically helping to inflate the cosmos?
That is an incredible thought.
It's an immense amount to think about, and it completely changes what it means to be an active participant in this universe. Thanks for taking this deep dive with us.